Hey everybody, welcome back to Dave's Math channel. I'm your host David Tare, and this is my continuing feature on the Math Lovers book, a three-volume series I wrote from 2019 to 2022 that's available on Amazon.com. You might want to check it out. It's available both, each volume is available both in paperback and in Kindle. I believe $30 for paperback, $9 for Kindle. I think they're a good bargain. You might want to check them out. But meanwhile, I'm doing a free feature on this channel. I'm going through the Math Lovers book, at least the first two volumes. And right now I'm up to section 3.2 of volume 1, which is on irrational numbers. And today, this is my third video on that section. I'm going to talk about radical expressions. So anyway, let's begin. So this is going to be a very brief video, by the way. I only have one slide here. So what is a radical expression? Well, I think you guys are familiar with square roots. I already did a couple videos on those. Those are just numbers whose square is equal to the number inside what's called the radical, the funny looking, symbol with a little, entry that you can put a number inside on the lower right. And the symbol for nth roots, it doesn't have to be a square root. You can have cube roots, fourth roots, fifth roots, roots of arbitrary degree. And you just write a symbol n on the top left to indicate that it's the nth root instead of just a square root. For instance, cube root you would write with a letter 3 on the upper left, fourth root a little 4, fifth root a little 5, so on. I don't mention this in the book, but I'm not really all that crazy about this notation myself. I prefer the power notation. You can also write square roots. A square root of n as n to the power 1/2. And similarly, you can write cube roots as n to the 1/3, fourth roots as n to the 1/4, or in general, kth roots as n to the 1/k. I prefer that notation. I just think it's less cumbersome. But this is kind of a standard notation, so you might as well get used to it. And another thing I think I should mention about radical expressions. You don't have to do this with nth roots. You can do this with square roots too, but you can nest them. So you can get very, very complicated radical expressions by nesting, various nth roots together. And I show an example of a very complicated such expression here. I haven't actually evaluated this number. I think it's imaginary, by the way. I think the radical expression on the right is not a real number. I probably should have chosen a little more carefully. I mean, it still makes sense mathematically, by the way. You can have square roots of negative numbers. They're just what are called imaginary numbers, but I'm jumping the gun here by mentioning that. But I think there's one more thing I think I'm going to mention before I get off. This is a very short video. Nth roots are examples of roots of polynomials, and they're actually very simple roots of polynomials. That's where the name comes from. So, for instance, the square root of n, like the square root of 2, would be the positive root of the polynomial x squared minus 2. In other words, the solution to the equation x squared minus 2 equals 0. There's actually two roots to that equation, two solutions if you like, plus square root of 2 and minus square root of 2. And similarly, nth roots are solutions to the polynomial equation x to the n minus whatever your number is. You're taking the nth root of. Let's call it k. So, for instance, the cube root of 10 would be the positive root of the polynomial x cubed minus 10 equals 0. And I talk about polynomials much, much later in my series, by the way. I'm really jumping the gun here because you don't have to know about polynomials from what I'm talking about right here. That's not even, I don't even talk about polynomials till volume 2. So I'm really jumping the gun here. But what else did I want to say? Yeah, I think the most interesting thing about all this is that you can write the root of any polynomial of degree up to 4 is a radical expression. It turns out, but you can't do it in general for degree 5 or higher. And there was a famous 19th century mathematician named Abel who was the first to prove this. But I'm really jumping the gun here. I just thought I'd mention that because it's a pretty important result. Anyway, any polynomial with degree 2, 3, or 4, degree 2 polynomials are called quadratic polynomials. X squared plus bx plus c. Cubic polynomials are polynomials degree 3, x cubed plus bx squared plus cx plus d. And fourth, quartic, they're called quartic if they're degree 4. Ax to the fourth plus bx cubed plus cx squared plus dx plus e. So those are all the polynomials of degree up to 4. And it turns out that all their roots can all be expressed as a radical expression, sometimes very complicated ones. Most of the time involving imaginary numbers, even if the roots are real. But for degree 5 or higher, in general, you can't do it. You can use other functions to express the roots, but you might as well just say they're the root of whatever polynomial you're talking about. So anyway, that completes my video for today on radical expressions. Thank you for watching. Long live math, and I'll see you guys next time. Bye.